Problem is 2369. Check if there is a valid partition for the array. I have done this like a few days ago, but I want to review and try another approach. Not really another approach, but kind of like the definition of DFS. I want to change it, so and I want to try it again to be more familiar. Okay. So the problem is you are given a zero index integer array nouns. You have to partition the array into one or more contiguous subarrays. So you can partition or not. And we can call a partition of the array valid if each of the obtained subarrays satisfied one of the following conditions. Okay, so the subarray consists of exactly two elements. For example, the subarray 2, 2 is good. Okay, so like if the partition consists of only two elements and both of the value are equal, then the subarray is good. Or if the partition consists of three elements and the three elements are all equal, then it is good as well. Or if the partition consists of three increasing elements and it has to be consecutive increasing elements. So yeah, and that will be seen as a good partition as well. And return true if the array has at least one partition, one valid partition will be okay. Otherwise, if no valid partition at all, then return false. Okay, so like you can have if like the nums is 1, 2, 3, 4, then you can have 1, 2, 3 or like 2, 3, 4 is also valid, then we will return true. Or if you have, okay, let's say you have can I have 0? No. Okay. And we can't have negatives. The array length should be at least 1. So you can have like 1, then it will return false. But if you have 1, 1, then it is true. And if you have like 1, 1, 2, it is true as well. Okay, so let's say if we look at the last element in nums, like here, so that's like if we look at the last two elements, if these two are valid, if it is like selected, okay, what else? if like these two are selected into a subarray, like into a partition, then if it is equal, then the problem will become trying to find, oh, if it is equal, then we already done it, like we can return true. Else okay, so we can keep selecting 2 or 3 elements here. Like if this is equal, then we can return true. If not, then we can try to see if this is valid, or like if this is consecutively increasing elements, then we can return true already. If not, then we can have this 3, like, and the ending element can is looping, and yeah, if not, then I kind of want to do it like if yeah, like the last 3 elements or last 2 elements, if it is valid, then the problem will become check if the rest of the subarray is valid. So I would have, oh, it is lagged. If DFS, I will have DFSI. I think since the problem is, okay, let's say if Si minus 1, like the last element, and Si minus 2, if the two of them are equal, then the problem if these two are equal, then return true. If not, like else if else if Si minus 1 equals Si minus 2 equals Si minus 3. Return true. Okay, if this or this plus 1, this plus 2, then return true. Else else we will have the problem like the problem shrinks to check if subarray, like check if nums till I minus 1 is valid or not. Yeah. And not for nums, till I means nums 0 to nums I minus 2. Yeah. Okay, so we can have DFSI defined as whether subarray, whether nums like whether nums till I is valid or not. And till I means till I minus 1. Okay, so DFS will have true if these are else DFS I minus 1. Okay, maybe we can, I am thinking of changing the I, like if this is like if we change the I, so it will be like whether nums 0 to nums I is valid, so it will be nums till I plus 1. Don't know if this so then we will have true if DFS I equals I minus 1 I or I minus 2, oh no, this Yeah. I think I will try to implement this one, and we can see the difference maybe. So the boundaries will be for this. Boundaries will be like the last element will be I equals 0, and I think like when I is 2, they're still okay. If I is 1, I is 0. If I is 0, then it is false, cause yeah. If I is 0, check only. If I is 1, sorry, check only I's. This one. If I is 0, return false. Okay, for this one, it will be, this will have like boundaries. If I is 2, then check only I minus 1 and I'm I minus 2. And then if I equals 1, return false. So let's say that's for the implementation, we'll have first write the boundaries. If I equals 1, we'll first have if I equals 0, then return false. Else like return can also have if like if I equals 1, then and we will have return DFS and minus 1. We haven't defined n yet, so n is the length of nodes. Yeah, let's see. Oh, sorry, no S. It's all nums. Change it here, smallest font. Yeah, my bad. Oh. Okay, let's check why is this wrong. We will try run. So for this is we'll have n is 4, so n minus 1 is 3. So we'll have 3 if 3 equals nums at 3 is 2. If 2 equals 1, no. Or if 2 equals 1, no. No. 2 equals, okay, no. Then else it will run to DFS 2. And then for DFS 2, this one here, return true if nums 2 equals 1. Yeah, so return true. And cause like here, it returns true, but it should be false. Why? At least one valid partition. Why? We can have one. One or more. Oh, like, okay, some misunderstanding. So we call a partition of the array valid if each of the obtained subarrays satisfies one of the following. Okay, so every partition has to satisfy at least one condition. So this will be false. Okay, so then yeah, so we cannot do it like that. It has to be Okay, so still we can look at the last element. If like if this is selected as a group, like if nums I okay, then like if nums I equals like has the following no, but yeah, it has to belong to at least one of the group, and it cannot be itself. Like it cannot stay alone. So yeah, like I'll have if nums I equals nums I minus 1, then the problem shrinks to find to check if nums I is like nums 0 to nums I minus 1 is valid or not. Okay, if it has another option, like if nums I it will be 2, so it will be minus 1. This will be 3, so it will be 4. And another option will be if it is increasing yeah, okay. So the DFS will be like if none of them meet, like none of the condition meet, I think you should return false. Okay, so DFSI, like, cause we want to check if like the partition ends at nums I, is it going to be a valid? Yeah, like this. It should be in the, at least in the group, like at least valid. Okay, so DFSI, the definition will be I think the same, whether nums 0 to nums I is valid or not. And DFSI will equal to I think will be the above this thing. So boundaries will be I, if I is like if I is 0, then return false. Okay. So we will have if I is 0, turn false. Then if I is like if nums I equals nums I minus 1, return DFS I minus 1. No, sorry, DFS I minus 2. Yeah. And if I is larger than 2, oh sorry, larger than 1, and this is or, return DFS I minus 3. Mm, but yeah, like it should be an end, like I will have result to default to false and rest. Yeah, like for for the array nums 0 to nums I, yeah, we haven't returned whether it is valid or not. So if like if this is valid, like if this condition meets and we check the previous thing and it is valid, like it returns true, then yeah, and else if it is not valid, so we'll have to return rest, but then we are not returning true here. So I think we'll have, yeah. And this will be true. Okay, and let's see. Oh. I think something wrong here. Yeah, my instinct says that something went wrong here, but let's see. So we'll try run this. This will be n is 5, so we will have df as 4. Okay, this is or Okay, so for it will be if this 2 is okay, this 2 is not equal, it will be here. Four is equal, no, or 4 is equal to yes and yes. And okay, so this is met, this condition is met, this is met, and we will see this one. So it will be DFS 1. So if DFS 1 equals DFS 0, yes. And if DFS I minus 2, okay, it's smaller. Okay, so this I is 1, so it is like -1. It will return false since it will not go into this condition, it will not go there, not go here. So it will have the rest false, it will have false, and so we cannot I think we should have I is larger than 0 here, and can have if I is smaller than 0, it's true, since it is an empty array. Yeah. Let's edit the catch. Okay, quite well. And we can turn this into a for loop. So first of all, we should make we should make an array to keep track of the true, false, the valid or not for each state. So I will have valid, and it will be I think we will have true at the first and false for the rest. Okay, and it will have like a dummy node because it represents like it's smaller than 0. It is not in like, yeah, we don't want to have extra checking, so we will have a dummy node here. So for I in range and +1, since like at the end we will have return valid n, because this is the length of valid array is n plus 1, and we will start it from 1. Okay, so if I is if I is larger than 1 and this will be 2, and no. Okay, let's first write like valid I will be true. I think we will have valid I plus 2 plus 1. Yeah. And this will be I minus 1. Yeah, since like the return value will be valid n, and before it is DFS n plus n minus 1, so all the index has plus 1, so every related to valid should be plus 1. Okay, and we will check for the index limitations. If I will start it from 0. Oh, we can have it like this. Yeah, like if 0. No, we should start it from 1. If I is larger than 0. So this will be correct, but let's see if this is this will be 0, so it will have true. And this will be it will be I think we can dry run for this, so it will have T F F F F F. Okay, so range n is 5, so I will start it from 0. Okay, so it is not passing, it is not going into entering into any condition, and then I now is 1. So for I is 1, does it have nums for like 4 equals 4? Yes, and is valid. 1 minus 1 is 0, so T is true. So it's true. Valid. 1 plus 1 is 2, so this will be modified to true. Okay, and it will not enter this condition. So, well, then we will have I is 2 now. If I is 2, I is larger than 0, and nums 2, 4, which is 4. Is it equal to nums I minus 1, which is 4 as well? Yes. And does it have a valid I minus 1? So it's valid at 1. No. Okay, so it's false. And yeah, it's correct, since if we make this to a group, then this it will be alone, and it is not valid. So yeah, so we will not change the value here. And if I is, yeah, it will enter this condition since I is larger than 1, and is the, okay, now it's 2, so this 4 equals this 4 equals this. Okay, and valid 0 is true, so it will have valid at 3 equals true. Okay, so this will be true. Then we'll move on to the next iteration, that I is 3. So So 3 for it is not equal, like for the 2, so we will not enter the condition. Then yeah, these 3 are not, so we will not modify any of the valid array. And then we will move on to the next iteration, that is I equals 4. When I equals 4, it is 6. Does it have, no, these 2 are not equal. And can we enter this condition? Okay, these 3 are increasing, so yes. And what is the previous array set? Is it valid? Like 4 minus 2 is 2, so valid at 2. It's true, and it is, since 4 is true. So we will multiply this to true, and yes, it is valid. Okay, then and submit. You'll have to remove this and okay, have I smaller than 0, return true, since empty array